Yeah, all of you listen here. That is a continuation of the voltage to frequency converter. Uh, uh, Still, some more things we need to discuss. Uh, Now, when VB1 is low, C reference discharge circuit is disabled and capacitance C reference remains discharged. So here, when you are dealing with when this is low, this is disabled, and this switch is in this position only. So C reference will remain in the discharged conditions only. C reference remains in the discharge positions only. The output VA, the output VA of the op amp is linearly decreasing. You can see that when VA goes slightly below zero voltage, output VC of the comparators switches low. Output VC of the comparator switches low. So here it is switches low. Comparator switches low. VC of the comparator switches low to zero voltage. 3 microsecond after VC goes low, VB1 switches from low to high. As I told that here, VB1 switches to low to high. Switches from low to high. This forces F0 low. This forces F0 low. F0 low, and enables the C reference charge discharge control circuit that will enable the C reference charge discharge control. So because of what happened is this switch is connected. Instead of connecting here, this switch is connected to here. It is connected to a minus 5 voltage. It is connected to a minus 5 voltage. Connect the C reference to the minus 5 voltage. At this instant, the negative voltage at the negative input causes output of the op amp to step up to a finite amount. So at this position, output of this will be step up to a finite amount, because suddenly when you are connecting like this, that sudden negative voltage effect will make this output to a high voltage. That is output of a V reference value. So output is step up to this voltage, V reference value. Step up to this V reference value. Yeah. To finite amount. The reference capacitor Cref remains connected to the reference capacitance C reference remains connected to V reference. This reference capacitance C reference is connected to this V reference voltage, minus 5 voltage. V reference. For the time period long enough to virtually charge it to V reference, capacitor to charge to V reference. The charging path for the C reference is through the output terminal of the op amp, through C-int, through CRF. So how the charging path? The charging path of this one is through this way, to this, through this, through this, through this, and to this way. I can say that this is the op amp output, through this way, through this capacitor, through this, yeah, no, through this, and it is through the negative supply. Now, since the output of the op-amp VA is positive, the output of the comparator switches from low to high. 3 microsecond later, VB1 goes low. So again, as you can see that VB1 goes low. Okay, when input goes means the op-amp output goes below 0 voltage, that time comparator goes low. After 3 microsecond, VB1 goes high. When VB1 goes high, it will activate this C reference charge discharge. So this switch is connected to here, and capacitor, what happened? It will charge, and suddenly it will charge to this minus 5 voltage through the what already I told the path. This will be charged through this way, and because of this, suddenly if you are connecting, that effect will be reflected here, and output goes to high voltage. That means a reference voltage. Yeah, a reference voltage. Then after that, because of after that, yeah, reference voltage. And after that, when it is because of the effect of the input current and this capacitor C integrator, the output slowly decreasing. This is the procedure it repeats. So this is the procedure it repeats. Now, when VB1 goes low, this disables C reference charge discharger circuit, and C reference is shorted out. Because of that, disabled means when this is disabled, this will be connected here. So whatever the charge in this, it will be discharged. This will be discharged. Okay. So remaining all I already explained. So here, so what remaining all already explained, you can go through once more. I don't want to explain further. There is a, you can see when you are observing, there is a self-start circuit here. Okay. That this circuit assures proper voltage to frequency operation when power is first applied. If the op-amp output VA is below the comparator threshold 0 voltage, if the op-amp output is VA is below the comparator threshold of 0 voltage, and C reference is already charged, then when the power is first applied, a positive voltage step will not occur in this. So this way, a positive voltage step will not occur. Now, in these situations, the output of VA of the op-amp continues to decrease until it crosses the minus 2.5 voltage threshold of the substart comparator. So output goes below to minus 2.5 of this threshold voltage. Once it goes below of the threshold voltage, once it 2.5 of the threshold comparator. When this happens, the self-start comparator connect through 20 kilo ohm resistor a negative supply voltage VSS to the negative input of the op amp. So when this is happening, what happened is this will be connected to this positions, and what happened is this negative voltage is connected through the negative terminal. So output is switched to a positive, VA is switched to a, and the op amp quickly go to positive. As soon as VA goes positive, the delta comparator is disabled. As soon as it goes positive, that means I need to say that initially, first when you are applying it, this is output here is low, and here it is high. That time this is enabled, so the capacitor is charged by connecting this to an charger. Now initially this may not goes to a high positive V reference, so it is keeps on going to the negative. As it goes below this 2.5 voltage, what happened is then the negative voltage is suddenly applied to this negative terminal, and that will make this output voltage a positive, and that makes this op amp to a positive level, and the cycle repeats.